Okay, so let's do the last one here. The last one says, during a chemical reaction, the function y equals f of t models the amount of substance present in grams at t seconds. At the start of the reaction, there are 10 grams of substance present. Okay, so that translating that to math would be, well, y of 0 equals 10 or f of 0 equals 10. I could kind of write that either way since y equals f of t. The function y equals f of t satisfies this differential equation. So, okay, so I have dy dt equals that. I'm just not that you have to write this by any means. Oops, y squared. What does letter A say? Letter A says, use the line tangent to the graph of y equals f of t at t equals 0 to approximate the amount of substance remaining at 2 seconds. Now, here's what I want. The wording of this problem is, and here's how you're just going to earn points. It says use a line tangent to the graph to approximate. So your brain should think linear approximation. What do you need to do to use a tangent line approximation? Well, if they say at t equals 0, the first step is going to be write the equation of a tangent line at 0. So the good news is you already have the point. So I will just kind of move my letter A right up here. So my point is y of z equals 10. There's my point. Now what's my slope? Well, I really need y prime at 0. Do I not? Now y prime of 0, isn't that dy dt? Because remember, this is y and this is t. So I need to use this equation to get my slope. Now be careful, because if you're doing it hurriedly, you're going to make a careless mistake. You're going to say, oh, I'm going to put in 0 for this variable. Notice that's y. What was the y value at t equals 0 was 10. So what I get for the slope is -2. So I have a point, I have a slope, so the equation of my tangent line would be y minus 10 equals -2, and I'm going to use the letter t just because it says y of t, so I'll put that. And obviously I could write that this way as well, move that y over. So that's going to be my first step. Now you write the equation of the tangent line to find the amount remaining at t equals 2 seconds. So in other words, I'm trying to find y of 2, so I'm just going to put in 2 for t, 10 minus 4, and that would be 6. What are the units? Grams, because it told you that. Now, what were the points for that? Well, you got 1 point for finding this derivative. So if you have y prime of 0 is -2, you would earn 1 point. And then there was 1 point for the approximation. Obviously, with the answer points, you have to have proper justification. Like you have to, write all that and show where you're getting that. You can't just all of a sudden get 6 grams. So even though that's easy and something that you could do in your head, you're of course showing where you got that. So that was letter A. Perfect, perfect. Now let's look at letter B. Letter B says that what? All right, where are you, letter B? Using the given differential equation, determine if the graph could resemble the following graph, give a reason for your answer. Okay. Now, I would probably go, all right, what do I notice? There's several things that you could do. To me, I try to get it in the fastest way. So the fastest way I see is this is the derivative. So they're asking, is this graph, could that be the graph of y? Okay. So using the given differential equation, determine whether a graph of f could resemble the following graph. So remember, f is y equals. So is y or f that graph? You already have the derivative. What do you notice about that derivative? Well, no matter what y is, if dy dt is -0.02 y squared, do you notice that no matter what you put in a y, this is going to be less than 0? So basically you're saying since the derivative is always less than 0, the graph of y, or f, must be decreasing always. Okay? Now you, and maybe I'm gonna put it this way just because I want to be totally accurate, because you go, wait a minute, y, if y is greater than 0, I mean, if y equals 0, then dy dx would be equal to 0, so it's not decreasing. I could say it this way. So I'm going to be super accurate and say, well, dy dt must always be less than or equal 0, so the graph of f must be non-increasing. And since the graph of f, or the shown graph of f has increasing segments or increasing portion, it cannot be true, or something to that effect. I mean, again, you don't have to have that exact wording, but you're explaining why that graph, you have this increasing piece right here, which would not be true. And that whole thing was worth 1 point. So you had to have a reason for that. If you just say no, they're not going to give you credit. So you have to have a calculus justification for that. All righty. Very good, very good. And part C. Erase this while I'm at it. What does part C have us do? Find an expression for y solving the differential with the initial condition. Y'all, here are the ones that every year it seems like when they ask you to solve a differential equation, people leave blank. And that's so harsh because those questions are usually worth big points. So I want you to get, maybe you don't get all the points, but you certainly need to get at least the first 3, in my opinion. So when it says, notice they asked me stuff about, I was using the differential equation, etc., but this one says, find an expression by solving the differential equation. Remember, in our class, if they ask you to solve a differential equation, the only ones we do are separable ones. So your first step is to separate the variable. So using algebra, I would do dy divided by y squared. Okay, be careful with your algebra. You don't want to miss it in the first step because of algebra, is equal to negative 0.02 dt. That's separating the variables, and that will be your step every time. The next step is I want to integrate. And remember, some people go, well, how did you know to put the negative over there? Or how did you put the negative over here? I can do it both ways. So don't let that be the thing that confuses you. How do I integrate? Well, that's really y to the negative 2. So think about integrating y to the negative 2. I increase the power by 1, so that's y to the negative 1, or 1 over y. And with a negative, and then I have negative 0.02 t plus c. And again, don't be confused, because if you did it without, if you kept the negative over here, you would have these as being positive. I'm going to get the same thing both ways, so that really doesn't matter. Make sure that you are putting the plus c right in that step right there. Now I'm going to use my initial condition. It said that f of 0 is equal to 10. So when I put in 0 for t, I should get 10 for y. So notice how I use my initial condition and I put in, because this statement right here, that's t and that is y. So I have 0 and 10, which that would give me c is equal to negative 1/10. Whether you do a decimal or fraction doesn't matter. I'll do it like this. just because I have the other one in fraction form, or in decimal form, so I'll leave it that way. And let's see if I can move this up a smidgen so I can continue it on one line. Now notice I go back to exactly the same spot that I plugged in the initial condition. I put in my C, and then my last step is to solve for y. And here's where, I mean, all those things are negative, so let me just divide through by a -1, and I would get 0.02t plus 0.1. I could change this to fraction form, but remember, it doesn't matter. So the quickest thing for me, if I want to flip this side, I would flip this side. And I would leave it like that. You don't have to simplify. You can, but I wouldn't bother. And so that's my answer. Now let's see where the points come from. You get 1 point just from separating the variables. That's why I say that point you should get. That's algebra. Be careful in doing that, but that's step number 1. Second point is antiderivatives. Sometimes this is actually worth 2 points, but this one you had to get both. Did you integrate both sides properly? Unfortunately, if you only integrated one side properly, you would not get that point. If you got both antiderivatives correct, you would get a point. Now, the third point is if you put C, you got to put it right after you integrate. That is super, super important. They stop grading if you don't, and you're guaranteed only 2 points, these first two. But if you put C here and uses initial condition to solve for that C. So you put in the 0 and 10 and you get the C there. The last point is, do you get down to that particular solution? Do you get down to this y equals? Okay, so sometimes that can get tricky. If there's a square root and you have to pick plus or minus, a lot of times that gets forgotten. So that's why I'm saying you may not get all the points. And like I said, sometimes this is worth 5 because they do these antiderivatives separately if they're more difficult. But at least get 3 points because these 3 you should hopefully be able to get. So that was point C. And then let's do point D. Okay. All right, so the last guy, let's see what letter D says. Letter D, that is really, really tough. Letter D says determine whether the amount of substance is changing at an increasing or decreasing rate. Okay, so what does that really mean? Because again, figuring out what they're asking you is the hardest part. Once you know that, you can do it. So what is that asking you? Remember, this is the rate at which it is changing. That's what a derivative is. That's what dy dt is the derivative. Determine whether the amount of substance is changing at an increasing or decreasing rate. So they're asking you about the rate of change of the rate, correct? So I basically need to see the second derivative, right? It's the same curve sketching relationships. I'm asking you if this is increasing or decreasing. So if this guy is increasing or decreasing, I have to look at his derivative and see if the derivative is positive or negative. So let me do that. So I'm looking here, and I'm using implicit to take the derivative of the derivative, which of course is the second derivative. Notice the notation. You have to have that correct. So this is the notation for that. If I took the derivative of the left, I would get that guy. Now the derivative of the right, remember that I'm taking it with respect to t. So power to the front is negative 0.04 y. That would be the derivative of with respect to y, and then I have dy dt because I'm taking it with respect to t. So I take this and I plug in what dy dt is, which is negative 0.02 y squared. So for a final, I get what negative 0.008, 3 zeros, 308 y cubed. Now let's think about the sign of that. Well, really, since y, I said at the beginning that y could be equal to 0, it really can't be equal to 0. So since y, because the substance is always going to kind of decay away there, then if y is greater than 0, we know it can't be negative, certainly, then this second derivative is going to be positive, right? Because if we know that y is a positive number, which is the amount of substance, then the second derivative, that should be t, the second derivative is going to be positive. So since that is positive, we've just said that the derivative of a function, which is this, is positive, the amount of substance is changing, at an increasing rate. There we go. Okay? And so the point count on that was, there was 1 point for you finding the second derivative, and then there was 1 point for your answer with reasoning. And so this is good to remember this kind of idea. We did that when we did implicit, really. When you found the second derivative implicitly, you have to remember that chain rule idea. And then plugging in what you had there. So that's a good one. I like that one. So there you go. Hopefully you got some points. And if you did not, you learned something to get you some points for the actual test. All right? Peace out.